Welcome to our exploration of enthalpy and Hess's law. Enthalpy, symbolized by H, measures the total energy of a system, playing a crucial role in chemical reactions. In chemical reactions, enthalpy change tells us how much energy is absorbed or released. This can tell us a lot about how a reaction occurs in real-world processes, like in combustion engines or even when you digest food. There are two types of enthalpy changes. In exothermic reactions, energy is released, warming up the surroundings, like when wood burns in a fire. In endothermic reactions, energy is absorbed from the environment, causing it to cool down, similar to an ice pack used in sports. Now let's dive into Hess's law. This law states that the total enthalpy change of a reaction is the same, no matter how many steps it takes to get there. Imagine you want to find the enthalpy change for a reaction that's hard to measure directly. Hess's law allows us to add up the enthalpy changes of multiple simpler reactions that lead to the same final result. For example, if you can't measure the enthalpy change of a reaction directly, you can break it down into parts that are easier to handle. Sum up the enthalpy changes of these parts, and you'll have the enthalpy change of the whole reaction. Let's work through a problem together. Suppose you need to calculate the enthalpy change for the formation of water from its elements hydrogen and oxygen. We use known enthalpy changes for simpler reactions involving hydrogen and oxygen. By cleverly adding and subtracting these known values, Hess's law guides us to the accurate total change for forming water. And that's how Hess's law empowers us to understand complex reactions through simpler, measurable steps, expanding our capability to explore the energetic change in the chemical world. Remember, whether a reaction heats up or cools down its surroundings hinges on the enthalpy change. And with Hess's law, no reaction is too complex to analyze energetically. Keep these concepts in mind as they're crucial for mastering chemical thermodynamics.